As the question says, a turn of radius 20 meter is banked for the vehicles going at a speed of 36 kilometers per hour. If the coefficient of static friction between the road and the tire is 0.4, what are the possible speeds of a vehicle so that it neither slips nor skids out? Let us first have a rough sketch of this problem, in which we are having a turn like this, which is actually inclined or having an angle theta. So let us say this is the center. So we are having a vehicle moving over here which can have only a certain speed which is in between a certain range of the speeds only. Let us take out this triangle out of this figure and let's work with this only. We can show it as a triangle like this, in which we are having a vehicle of mass m having a force mg downwards, and this angle is theta, and if this block is moving turn actually, then there must be a centripetal force. Let that be mv square by r. So we are having mv square by r. Now we have considered this force to the right because now we have discussed the problem with respect to this triangle, I should say, which is a wedge-like structure. So this is actually the centrifugal force in the outward direction, which is equivalent to the centripetal force. If you take that into consideration, consider the acceleration also, and you will get the same equations thereafter. So framing the equations, if I assume the normal reaction to be n, then I can write from this that this normal reaction is equals to mg cos theta plus the component of the centrifugal force, which is mv square by r sin theta. Let it be equation number 1 and proceed to the equation which is along this wedge, writing it as, now if we are working when this block tends to move outward, then the friction will be in the opposite direction because it will oppose the relative motion. So the maximum speed when the block will be having a tendency to move out, that is skid upward, then the frictional force F will act in the opposite direction down this wedge in order to balance this block. So this is the condition for the maximum velocity when the friction is acting downwards. So framing the equation, we get mv square by r cos theta equals to friction plus mu mg sin theta, and marking it as equation number 2. Let us solve the equations where friction is equals to mu n and n is given in the equation number 1. We can easily have v equals to under root of rg mu plus tan theta upon 1 minus mu tan theta, and putting the values giving us 15 meter per second, giving us 54 kilometers per hour. So the vehicle cannot have a velocity more than this. Moving ahead with this question, that is the B part, let it be the A part. Then in the B part we are having the same situation, that is a block of mass m and mv square force by r, force that is a centrifugal force to the right, mg force downward, angle theta, a normal reaction n upwards. But since we are working for the minimum speed, then this block will have a tendency to fall along the wedge. And to avoid this, a friction force will act along the wedge in the upward direction. Getting my point? The friction is actually avoiding the relative motion along the wedge. In this case as well as in the previous case, that is the A part of this question. So framing the equations again, we will have here the equations as normal reaction equals to mg cos theta plus mv square sin theta. Sorry, this is mv square by r because we are having this angle as theta. So this is one of those equations, and the further we can have that friction plus mv square by r cos theta is actually equals to mg sin theta force. Solving both of these equations, we have velocity equals to, that is the minimum one, equals to under root of rg minus tan theta minus mu over under root 1 minus mu tan theta. Putting the values here, we get 4.08 meter per second, that is 14.7 kilometers per hour. Now friends, as I look back, I find that this mu I wrote by mistake because this will be only the component of gravitational pull, so obviously it had to be mg sin theta. There was no role of mu over here. Obviously the friction will be having the mu only. So now we can say that the velocity maximum that can be here is this one, while the minimum is this one. So the vehicle must have a speed between these two velocities in order to avoid the slipping or skidding.